We started out with some really cool ground fog this morning, and it gave way to this patchy cirrus and a little bit of sundog activity. I don't know how well that shows up on this cheap camera, but it was pretty neat when I was out there looking at it. Coming from this cirrus associated with this subtropical pattern, you can see we're picking up a little bit of a flow from the southwest from the Gulf of California and northwest Mexico. And some of that is associated with this Pacific system moving inland. I don't know if you recognize the pattern here. Maybe I can zoom that out just a little bit. Let me do that real quick. So this has a very characteristic shape, and you might recognize that comma pattern. So what we have going on here is essentially a jet coming in the backside, and we have the main upper level low in this area right here, and then the main baroclinic wave is kind of out ahead of it. We might find a short wave maybe kind of in this area right here. So ahead of that, a lot of ascent. This is a lot of mid-level lift ahead of that system, like at 700 and 500 millibars. And a little bit of lee side cirrus from Denver south through Lamar and Garden City and down to Amarillo. And out to the west, another system coming inland, and you might recognize a similar shape. And this is what we call a baroclinic leaf. And again, this represents lift ahead of a wave that is just trailing that. And also, similar pattern with a jet. We would find that jet a little bit to the north of that baroclinic leaf. And let's see if we have a water vapor imagery. We haven't really looked at that in a while, so yeah, we should definitely do that. And let me try to find a good enhancement curve here. I'll crank these values up a little bit and crank the zoom factor down. That's probably a little bit too close. And here we go. Here's that baroclinic wave right here. And you can see that we find the jet kind of in this area right here, and we see the downward branch of subsidence on the left side of the jet right in this area here. And on the other side, we have the area of ascent on the other side. And it's really these sharp gradients here that help indicate the location of the jet stream. Here you don't see a very strong gradient. Same here, but it's very sharp here, so you can use that to your advantage to place the jets. And a similar situation out here, you can see very sharp gradient right there. So we might think about maybe a jet right in this area, and not so much really in this area. Now, I have a feeling that there probably is a jet coming in through here, but if we saw this tighten up, that would kind of confirm that fact. So what do these represent? This is water vapor, as I mentioned. This is the goes west water vapor. We're seeing a measure of the radiation that's making it up to the satellite. For instance, right in here, there's relatively warm air at the surface. And the important thing that what we're seeing here on the water vapor imagery, this is a channel where water vapor tends to block the signal from the Earth's surface up to the satellite. It's what we call the water vapor window. Now, this radiation right here, it's not being blocked by water vapor, and it's making it directly to the satellite. So that's basically what you see there. And it appears warm to the satellite. In this location right here, we might have warmth underneath it. That's certainly possible. But the important thing is that even if that warmth is down there at the surface, like down here or down here, it's being blocked on the way up. It's being attenuated by water vapor, and as a result, very little comes out the very top of the cloud. So the satellite sees that as cold. And so that cold signature is just kind of a proxy for a lot of water vapor. Now, the same thing is kind of going on up in Canada, but it happens to be dry up there, and you might wonder what's going on up here. What's happening is there's very little radiation coming skyward to begin with. This is very cold. There's very little energy, so the radiation output is very weak. And so to the satellite, that looks cold. So just to kind of sum that up, where you see the red and darker shades, that's likely going to be warm and dry. And when you see these cold shades, that's going to be moist or cold, one of the two. And that's an important distinction, cold or moist. It could be either. So it does kind of get tricky when you're analyzing systems well up to the north. So we can probably consider that our little building block. I guess we'll just kind of throw that in a little bit early and proceed on with our analysis here. This is a SPC mesoscale analysis. I figured I'd throw a little bit of this in. We haven't done much with that, with it being winter, but I pulled down the upper air 700 millibar analysis, and I got this chart. This is showing conditions at about 10,000 feet up. In the screen right here, this is all high relative humidity. And values of 70% and above, those are going to be associated with cloud material. And not surprisingly, we find a lot of convection associated with that. See the radar here showing elevated convection through here. So it's kind of embedded in that area of ascent. And you can see the main wave indicated by the heights right here where it sinks southward. Main wave is going to be right back here. Okay, low temperatures overnight, they've been pretty mild across the U.S. Here we had 40s, a lot of 30s and 40s in Texas, and that's a little bit above average. Also pretty mild up north, just a lot of single digits and teens, and that's a big contrast from the minus 30s that we had last week. And we can see in the wake of that Pacific system, it also looks pretty mild. These are close to seasonal lows, maybe a tiny bit on the cool side. And let's go ahead and do our air mass analysis and get an idea of where the fronts and weather systems are. And I usually pick out this chart from MAG at INSEP because it's a little bit more legible for these webcasts. So there's our 500 to 1,000 millibar thickness. So it's pretty obvious we've got probably a front just kind of trailing on back to the Gulf of Mexico. Very similar to what we've seen over the past few days. And this goes up the Rio Grande. So a little bit of a warm air advection pattern across Texas and Oklahoma. And we can see the next system coming through Arizona, New Mexico, and northwestern Mexico. And there's our next system off the California coast. So that's on the way too. Now, one thing I wanted to do, and I keep forgetting to do this, is why don't we do some cross sections and look at the air mass. Let's try setting a cross section from off the Baja California coast up to Washington. So along that line. I've got the data all loaded up. And all I have to do is set the cross section. And for whatever reason, it's WinGrids has decided not to generate our reference map. So let me see what's going on here. Oh yeah, that would help. We need to open our data file, so let's do that. Okay, we're going to go to Display Cross-Section. I really should do a WinGrids workshop. That might be kind of popular there. Okay, I'm going to set a point right here off Baja California and another one up in Washington. Okay, so we've got some sort of error there in WinGrids. I'm going to give that one more shot, and if that doesn't work, I'm going to go ahead and move right on. WinGrids can be a little bit finicky. One thing I might try is changing the forecast hour. I'll try running that up to 12 hours, and I'll go to Display, Cross-Section, and Map Select. And wow, looks like it took it that time. Okay. It's like playing the lottery here with some of these programs. Okay, I'm going to go to Products, and I'm going to click on the time, or yeah, the time series. I'm basically just getting this chart set up here. And what we're looking at right now, this is that cross-section from off Baja California to off the California coast, and then to Washington. And what we're seeing here is essentially the brown lines are isotropes. That's lines of potential temperature, sort of like temperature adjusted to 1,000 millibars. In this gradient that you see right here, that's the stratosphere. Above that line right there, that's the tropopause, and above that is the stratosphere, and below that is the troposphere. And you might wonder, what is that telling me? Well, I can see a jet stream right here in yellow that's located over Washington, and I can see a little bit of maybe a frontal boundary right here, and I'm going by the tighter shading right in here. So basically what we're looking at on that chart this is a cross-section, so basically this is the ocean surface. This is 18,000 feet, this is 30,000 feet, and that's about 50,000 feet. And remember that this is off the Mexican coast, and then we go north, and then this is the Washington coast. So let's look at the changes over time. That's very interesting. This kind of gives us an idea of how the air mass is changing. So I'm going to roll this forward, and you're going to see the lines changing. So we step forward 6 hours. So this is about 12 hours. This is 18 hours in the future. And that should be about 24. So you can see it tightening up a little bit in this area here. This is going to be a little bit of frontogenesis. Looks like the frontogenesis here along the California coast, that's elevated. This is up in the upper levels. So this is probably, this could be a subtropical jet. I'm saying it could be. No, actually, the entire frontal surface extends down to the ground. Yeah, here it is. So, yeah, this is going to be a polar front jet. So you see that right there. This is the frontal boundary, and then above that, the polar front jet right there, and the core is located here. And behind that, there's our cold air mass. So off the coast of maybe Eureka, Arcata, and Fort Bragg, Basically everything from the surface up to the tropopause is a cold air mass. And we'll look at a little bit more of that and go forward. And that's about all I got right there. Anyway, I just wanted to show you a little bit of the cross sections. I'm going to try to work a little bit of that into our forecasting lessons here, because it's a good idea to look at the atmosphere three-dimensionally. And I'll give you one little bonus cross section. I'm going to do one across Texas up to Kansas, or maybe Nebraska, and we'll just plot a very quick one. And I'm going to run this to 12 hours in the future, so that's basically going to be midnight tonight. So let's check out what the isotropes look like. There we go. So Texas, Oklahoma, Kansas, and Nebraska. So this is showing probably right here, the top of that polar air mass located right there. And a pretty high tropopause. And out here, there's the polar front jet in the Central Plains. Okay, so that's about all I got for that. Just a little bit of playing around there with the cross sections using wind grids. So I think it's time to look at the forecast. So let's get these charts set up. There's the current picture. You can see the Pacific System coming in through New Mexico and Colorado in the Four Corners area. Got a busy chat here. I'll just say hello to everybody, and I can see all the usual people here, Alexi and Ron and Everardo and Mike, and probably a couple of other people I've missed. And also some chat in here. People talking about White Christmas in Mexico. Yeah, I hope you get a White Christmas there in New Mexico. New Mexico. I didn't mean to say Old Mexico. Yeah, that would be great. Yeah, it doesn't look like they're going to get another system moving through there. Does NOAA or other sites have surface charts for your region? Let me answer that question real quick. We have a viewer asking about surface charts. And what you'll want to do is go to a search engine like Google, put in Aviation Weather Center. And once you're at the Aviation Weather Center, you're going to go to METARS. And then there's this link at the bottom. Now, yeah, you do get a chart up here at the top, but I like these plots a little bit better. And let's see, Felix, I'm not sure where you're located, Felix, but say you're in Nevada. You just click on that Winnemucca symbol there, and you've got yourself the latest METAR chart for that area. There it is. So it's pretty much as easy as that. And I like to use digital atmosphere because it's a little bit more detailed. And I do have the option in digital atmosphere of changing the items that I have in the plot symbols. Like I could just have temperature and wind and nothing else. So you get a little bit of flexibility there, and you can do your pressure analysis and stuff like that with that. Pressure analysis and moisture, like you can do mixing ratio. So that's more of a sophisticated solution if the Aviation Weather Center website is not giving you enough info. And the cross-section, the program for that's going to be wind grids. And I'll give you the quick link to that if you want to run wind grids on your own. There you go. It's windweather.org. And the program is free, but I'm going to tell you that it is not all that user-friendly to get up and running. You're going to have to read the manual. and the manual is about 250 pages. So there is a little bit of a learning curve on that, but if you have some spare time, definitely try that, and I will try to do a workshop on that in the next month or so. And are the solar flares affecting weather? No, not. I seriously doubt it. I wouldn't be surprised if maybe on rare occasion that they might affect the radiation budget a little bit, but for the day-to-day weather, there's not going to be an effect there. So let's head into the forecast and see what we're looking at for Christmas. Let me get that centered right there. So we have the current picture there. We're dominated by high pressure in the east and central U.S. You can see that clockwise flow around that high. And we'll run the map forward for the webcast tomorrow. Friday is here, Christmas Eve. Actually, no, tomorrow's, sorry, false alarm, it's only the 23rd tomorrow. But there you go. We get the first system. That's basically the cutoff low from New Mexico pulling rapidly to the northeast. And because of that very fast motion, that tells us that the system is mostly elevated. So a lot of mid-level precipitation with that. And as a result, we're not going to see much in the way of surface precipitation with that. Now we have Christmas Eve, and that's going to be Saturday. And with that, we're going to get this big Pacific system developing and maybe some snow there for Felix. Certainly possible. The timing for that is real good. And the cold front is going to look like that. And I'm going to tell you right now, this is going to be a good opportunity to practice your surface analysis, especially in the mountains where it is kind of tricky. As it's going through Utah and Arizona, that'll give you a little bit of a workout right there. So that's kind of what I'm looking at, and as I've pointed out, this is an antifront. A lot of the precip behind the leading edge of the front. Then Christmas morning, yeah, snow showers there for Mexico, New Mexico, and Colorado, and Wyoming, and the Great Basin area. So it looks like Salt Lake City and Twin Falls, Boise, Rawlins, Grand Junction, Trinidad, Alamosa, Albuquerque, all the way down to Truth or Consequences, maybe even Silver City getting a little bit of snow there, and the mountains of Tucson. But then we're going to warm up a little bit during the day. Christmas during the day, system moves rapidly up into the Dakotas. Cold front is going to look like this. And we've talked about the track of the system and the relationship to heavy snow. We're going to find the heavy snow to the left of the track. So that's going to be your target area for travel problems there in North Dakota and northern Minnesota. And especially as we get on the backside of that low right there, that's where we start picking up a lot of dry snow with the lower relative humidities and colder temperatures and blizzard conditions with that tight pressure gradient there. Then Boxing Day on the 26th, yeah, just right on time for Canada. And there we go. There's that cold front. Kind of straggling into Texas and Arkansas. Very weak push back here. Most of the push is going to be eastward through the Great Lakes area. So there you go. Mostly a Canadian snow event. And behind that we can see the Pacific air mass moving into the Rockies. For the 27th on Tuesday, kind of a quiet day across the U.S., mostly dominated by high pressure and this lee side trough. Then for the 28th, looks like we get a little bit of building on that Great Basin high, and that's going to drive a little bit more cold air southward into Texas. There's the new front pushing southward. For Thursday the 29th, looks like again most of the push on that cold air is going to be eastward, but a little bit more of that makes it down into Texas. So a big high right here, and most of the cold air advection heading this way, and a little bit less into Texas like that. Then on the 30th, on Friday, another Alberta clipper making its way southward. Going to be kind of mild for Texas and the southern U.S. And then on New Year's Day, that Alberta clipper really builds steam, and we get a big norther moving southward into Texas there. So very strong cold air advection. Now it's more towards the Great Plains right there. And then New Year's Day. Going to be a bit of a snow event for the northeast U.S. and the main cold front will drive southward. And looks like we got another shot of cold air building back here with this anticyclogenesis. You can see that 1048 millibar high. And really we want to look at the Canadian model and see if it's actually going for that too, because this is out at 250 hours. And the Canadian model has actually been a little bit better than the GFS. So for the 3rd and 4th, just looks like more cool weather, succession of cold air outbreaks moving southward. And then we get to the end of the run. And looks like it just becomes a more progressively cool pattern for the central and Midwest states. So I think that's about all I got for today. I'm about talked out here. We've done 27 minutes. So I appreciate you all watching, and I hope you all learned something, at least with that cross-section stuff and the water vapor imagery. And if you have any questions, definitely leave that on the comments on the videos. I'm sorry I haven't really gotten to that, but I'm going to go through probably tonight or tomorrow and catch up on YouTube comments. Okay, I appreciate you all watching, and hopefully we'll see you tomorrow.